Okay, so today we're just going to be taking some quick notes on fission and fusion. This is page 31 of your notebook. It's section 2.3. For today, the goal is just for us to be able to tell the difference between fission and fusion. So, you may have heard these words before, and fusion is used in other contexts besides nuclear chemistry. So when you fuse things together, that means you combine them. So fusion is where you take two smaller elements and combine them into a larger element. This happens mostly in small elements. So for example, hydrogen, helium, these are elements that do fusion. Those are the smallest elements on the periodic table. Fusion is very common. Well, fusion is what happens in stars. So our world is actually powered by fusion because the sun produces energy through fusion. The sun is not burning in the same way that like a log burns. It is actually doing nuclear fusion, and that's how it's producing its energy. So one of the great things about nuclear fusion is that the byproducts, so things that are left over after it happens, are not radioactive. So one of the problems with nuclear power, of course, is that it produces radioactive waste. But if we could use fusion for nuclear power, it wouldn't produce the same kind of radioactive waste as what we currently have. So you might be asking yourself, well, why aren't we using it? Well, there are some major obstacles to getting our power from fusion. We're going to talk about two of them. The first obstacle is that it is very hard to get enough heat to make fusion happen. So think about how hot the sun is. You need to get up to temperatures close to that to make fusion occur. Otherwise, the elements won't combine. They have to be going fast enough to ram into each other, and that requires a lot of heat. So it's just hard to generate that heat. And then the other problem is that once you do generate that heat, you have to contain it. So think about trying to contain the heat of the sun in a building on Earth. That would be very difficult and very expensive. So that's another big obstacle. Now, people are researching nuclear fusion, and there are actually labs and places where people do fusion, but they don't do it at a big enough scale to actually power anything. So we do have fusion reactions going on Earth, and people are working on it, trying to figure out how we could power things through fusion, but we have not gotten there yet, and we are a ways away from being able to use that to power anything. Okay, the other nuclear process that is the opposite of fusion is called fission. And fission happens when one larger element splits into two elements. And this happens with bigger elements. So things like uranium, and it's used in nuclear power plants and also in nuclear weapons. And one of the problems with fission is that it produces radioactive waste. So there are some major downfalls to using fission as a power source. So one way that you can remember the difference between fission and fusion is to look at the number of S's in each word. So fusion has one S, and in fusion we're making one element. So fusion, you end up with one element. Fission has two S's, and in fission we split an element into two. So in fission you end up with two elements in the end. So you can remember fusion, 1s, combined into 1. Fission, 2 s's, split into 2. Okay, last thing we're going to write down, you need to be able to look at a reaction and tell me if it is a fission or a fusion reaction. So here's our first example. This is 2 hydrogen atoms combining to form helium and a neutron. So hopefully you can see that this is fusion. We've got 2 smaller elements, they're combining into 1 element. The neutron is not an element. So we've got 2 things forming 1. So that's fusion. Now if I have something like this, so we're going to start with uranium plus a neutron, and we're going to form barium and krypton and a couple more neutrons. So you can see, if you ignore the neutrons again, we've got 1 element splitting into 2. Also, this is a much bigger element. So this is a fission reaction. This is what happens in nuclear power plants and nuclear weapons, in fact, this exact reaction. All right, so that's fission and fusion. Just make sure you get those notes copied down.